guys. Good afternoon. We are live. Actually, we want to start our okay. So we start our live. So now we are going to solve. We're going to help each other to understand what we're supposed to do in paper one. Actually, because a lot of students actually complain about mathematics paper one. Getting low marks. So as I'll be solving, actually there are things that I'm going to be telling you, and make sure you take them down, so that as you tackle any mathematics paper one, you know what you're supposed to do. This is a skill that you might not even learn it in your schools. So make sure when you learn that skill, if you're going to learn something from this live, you actually subscribe to our channel so that you learn more, and you can see through there's some videos also, and also share to others. Okay, so let us start. Our first question that we are going to handle is simplification. So they're saying simplify, okay, simplify. So we are simplifying, that is 2, simplify 2, open bracket, x plus 3, close bracket, minus 3x, open bracket, x minus 2. So when they ask you to say simplify, don't start panicking. Okay, the major issue here, they're asking you to make it simple. Okay, so we are going to make it simple. That is all what they're asking us. Okay, so from here, for us to make it simple, first of all, we need to check on the brackets. Of course, we have brackets. So what we're going to do is, first of all, to remove the brackets. Okay, so let us multiply with the 2, which is outside here. So 2 times x, we have 2x. Okay, 2 times 3, we have positive 6. Then negative 3 times x, negative 3x squared. Then negative 3 times negative 3x times negative 2, we have positive 6x. From here, we are now going to use grouping method. Okay, we're going to put the like terms together. So the 2x and the 6x are like terms. So 2x plus 6x. All right. Then the positive 6 and the negative 3x squared, they don't have any like terms, so they will come as they are. Then from here, 2x plus 6x, so we have 8x plus 6, then minus 3x squared. This is our answer. We have simplified. Okay, the next question. The next question is saying evaluate. Okay, so we are evaluating, that is open bracket, cube root of 27, close bracket, to the power 2. So we are trying to evaluate this. Okay, so first of all, we need to take out the root. Okay, so in this case, what does it mean when we say cube root? We mean look for a number that you can multiply 3 times by itself to get 27. Then that is the answer, and here it means you have removed the square root. So that number that we can multiply 3 times to get 27 is a 3. Then outside we still have a 2. Okay, then 3 to the power 2, that is 3 times 3, okay, which will give us a 9. Okay, so this is the answer we have evaluated, question 2. If you have any question, please, you can go ahead and ask that question in the comment section. All right, we proceed. The other question is saying factorize completely. Okay, factorize completely x squared minus 100. Factorize completely x squared minus what? 100. Okay, so here, let me just cut here. Okay, so we're factorizing completely. That is 16x squared minus 100. Okay, such questions, no need for you to start panicking. Okay, such questions, they mean you need to use difference of two squares. Okay, sorry for the sound that you're hearing. So here we're going to use the difference of two squares. But first of all, we need to find what is common. It needs to be simplified before we can begin to use that. So simplifying this, we are going to find what is common. If we check for the letters, no letters are common. Okay? But the numbers, we can find what we can divide. The same number reducing 16 and the same number reducing into 100, which is a 4. So 4 into 16. So what is common is a 4. We take it outside. So 4 into 16, here you're going to have 4x squared. Then 4 into 100, you have a 25. Okay? Now, whatever remains in the brackets now, that's where you're going to use now the difference of two squares. How do you use that difference of two squares? So, you need a number, 4 and 25, they need to be broken down into index form with a power of 2. Meaning we need to find a number that we can multiply 2 times by itself to get a 4, at the same time also to get a 25. So for us to get a 2, multiplying that number 2 times by itself, it's a 2. So 2 squared minus, for us to get a 25, multiplying a number by itself, a 5 squared, like that, okay? So from here now, we can begin to use the difference of 2 squared now. So from here, I'll just write the bases. So 2x minus 5 in the first bracket. The second bracket, I'll have 2x plus 5. This becomes your final answer. You have factorized completely. All right. We go to the next question, question 4. Okay. Question 4 is saying the points A, okay, the points A and B, okay, the points A and B are -5, okay, -5, 15, then the 3w, w respectively, given that the midpoint of the straight line joining A and B is 5, 10. Find the value of w. All right. So here, for us to be able to solve this question, they've mentioned of the midpoint. So in this case, because they've mentioned the midpoint, it simply means they want us to use the formula for the midpoint. Okay? So we'll say the midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. This is equal to the x, comma, y, which is A and B, the midpoints. Okay, so here, I'm going to use these points that have been given there. Okay, so the -5 and the 15, this is x1, y1, then 3w, comma, w, this is x2, y2. Okay, then the midpoints are 5, 10. Okay, so let us substitute those values. x1 is -5 plus x2 is 3w, okay, over 2, comma, then y1 is a 15 plus y2 is a w over 2. Everything equals to these 2 points there. Okay, so now from here you just pick one. Okay, you just pick one. So I can get this. So these values here are for y, these are for x. Same here, this is for y, this is for x. So if I get this expression, I need to equate it to the value for y. So if I have 15 plus w, okay, over 2 equals to, since I've gotten the values for y, I'm supposed to equate them to a value for y that side, which is 10. So from here, we can say over 1, we cross multiply. So 1 times everything here, we have 15 plus w equals to 2 times 20, 2 times 10, that is a 20. Okay, then the 15 has to cross the equal sign, so we have W equals to 20 minus 15. Okay, so 20 minus 15 is 5. So the value for W is 5. Okay, so far, any questions, guys? If you have a question, please go ahead and ask. Go ahead and ask if you have a question. Right? Okay, we proceed. Question number 5 is coming from vectors, saying the vector RS, okay, vector RS, so that is question 5, saying vector RS is given by -5, -4, then a 3, then the points R is given as -2, 1. Find the coordinates of S. Okay, find the coordinates of what? S. Okay, now this question, the way you're going to be handling this question is in a form of position of vectors. Okay, these are normally position of vectors. So position of vectors, they start from the origin. So I'm going to be drawing this shape here from the origin to my two vectors. In this case, these are R and S. Then I'm going to connect these. Okay, position of vectors always start from the origin, from here. Okay, so the arrows are supposed to be like that. Then at the same time, we've been given this vector RS. Okay, so this vector RS in column vector is -4 and 3. Then the R of a vector, a column vector, to be OR equals to, which will be a -2 and a 1. Okay, so this side here we have a -2 and then 1. So we are trying to find this which is not known. Okay, so here what we are going to do is to find using vectors now. Okay, so we are finding OS first of all. Okay, before we can write the coordinates, we need to know the vector. All right, so OS. Okay, so we're going to go OR. Okay, plus RS. This is how we're going to go. So our vector OS will be, OR is a positive because we are going in the same direction as the arrow. Okay, so it will be a positive, so which will be a -2, 1, this vector, plus RS also will be a positive, we are going in the same direction as the arrow, so -4 and a 3. Okay, so from here, what is -2 plus -4? Okay, from here, -2 plus -4 will just give us a -6. 1 plus 3 will give us a 4. This is the column vector for OS, but the question is saying coordinates of S. So coordinates of S will be -6, 4. This will be the answer now. Okay, this will be the answer right there. Okay. We go to the next question. If we have questions, please let's go ahead and ask. Okay, you can type that question in the comment description and then I'll be able to respond before we go to any question. So please, if you have any question, you can ask. We go to question 6, and this is a set. Okay, on the Venn diagram in the answer space below, shade set A complement, okay, shade A complement intersection B union C. Okay, now this one here, mostly what I advise my students is to just write down elements in these particular sets. Okay, this will help you to identify where you're going to shade. So let us put numbers like maybe 1, 2, 3, 4, 5, 6, 7, 8 times. Okay, even in the exam, you do the same, write the numbers in there with a pencil. Okay, put the numbers. This will help you to find the correct region you're going to shade. Okay, now check what will happen. First of all, let us find A complement. So a complement means elements that are not members of set A. Okay, so this is set A, B, and C. So members that are not in set A, we're just going to remove 1, 2, 3, 7. These elements will remove. Then the rest are the elements that are not in set A, which is 4, 5, 6, and 8, including this which is in the universal set. Then now, let us write so this is the A complement, okay? 4, 5, 6, and 8, all right? From here, intersection with B union C. So, union means combining the elements. Let us put together the elements of B and the C. So, the elements in B and the C are these elements that you are seeing here. Putting together, we'll have 1, 2, 3, 4, 5, 6, and 8. Now, what is the intersection here? What is common in this set and this set here? Then that becomes our final answer. So we even know where we're going to shade now. Okay, so the final answer will be, so we have numbers like 4, we have numbers like 5, 6, and 8. So 4, 5, 6, and 8. Where is 4, 5, 6, and 8? Have you seen where the numbers are? 4, 5, 6, and 8. Meaning we're shading where? Meaning we're shading where? Okay, are you able to get me, guys? Okay, my microphone is turning off. Just give me a moment, I switch on the microphone. Okay. Okay, now we can continue. So from here, we can proceed. Oh, sorry. So this one, the 8 is not there because it's a union of B and C. Okay, so we are just ending on the, where is it? That is 1, 2, 3, 4, 5, 6. Okay, I hope you're able to get me on this other microphone. Okay, so these are the numbers that you're seeing here. So we're going to shade this portion here. So this is the correct portion. Okay, for A complement intersection B union C. This is the portion that you are supposed to shade. Okay. All right, we continue. This was question 6. If you have any question, please go ahead and ask. Go ahead and ask. Go ahead and ask. Let me check if we have any questions before we proceed. Okay, no questions, no questions. All right. Okay, so we continue then. Since there are no questions, we can continue since there are no questions. All right. So, question 7. Question 7 now is on sets. Okay, on the matrices. As you can see there, so we are having 2 matrices. So it's saying given that M is equal to this particular set, so M is equal to, say, 3 by 2, so negative 3, 4, and 0, then negative 1, 2, and negative 2. Okay, then N is negative 2, 1. Okay. So from here, question A is asking us to find T transpose. Okay? They're saying find M transpose. So to transpose a matrix simply means to interchange the rows in 2 columns or the columns in 2 rows. That's what it means. Okay? So in this case, a column like this one will be changed into a row. Okay? Same applies this column into a row. So this first column will be the first row. So we'll have elements like negative 3, a 4, and a 0. So I've interchanged this from a column to a row. Same, negative 1, 2, and a negative 2. So this is the final answer there. Okay? We go to the next. They're saying find the Mn as a single matrix. Okay, we're supposed to find Mn as a single matrix. Okay? So Mn as a single matrix simply means multiply these two matrices. Now, one tricky thing that you need to remember, this is a tip. Okay, what's the order for this matrix here? It's a 3 by 2. This is my first matrix. Okay, then the order for this matrix here is a 2 by 1. So after multiplying, okay, after multiplying, I'm supposed to get the matrix which has an order of, I'll get the row for the first matrix and the column for the last matrix. It will be a 3 by 1 matrix. Okay? So if we miss it here, it means we have not found the correct answer. So let us now start multiplying. So we're multiplying matrix M, that is a negative 3, 4, 0, negative 1, 2, and a negative 2. Okay, times negative 2, 1. These are the matrix there. Okay, so the way we multiply, it's row by column. Okay, so the first number in this row is a what? A negative 3. All right, it will be multiplied to the first number in this column, which is negative 2. So negative 3 times negative 2. Since I'm still in the same row, okay, second element in this row, I'll multiply to the second element in this column. Okay, so negative 1 times 1. Now, as you are going to the second element, you put plus. So negative 1 times 1. Okay, we are done. If we had another column here, we would have left space and started multiplying from here. But because it is just one column, we end here. Okay, so we go to the next row. Again, down here, 4 times negative 2, then plus 2 times 1. So 2 times 1. Come down again, 0, okay, times negative 2 plus negative 2 times 1. Okay. From here now, we can multiply. Negative 2 times and negative 3 times negative 2 is positive 6. Okay. Then here negative 1 times 1, it's a negative 1. Okay. 4 times negative 2, it's a negative 8. Okay, 2 times 1, it's a 2. All right. Then 0 times negative 2, it's a 0 plus negative 2 times 1, it's a negative 2. Then this now will give us the answer of 1 plus negative 1. I mean, positive and the negative there, we remove the brackets first of all. So positive times negative, we'll have 6 minus 1. Then here, the final answer will give us what? That is, we are subtracting here different signs, okay? And getting the sign from the bigger number. So if we get a 2 from there, we remain with what? 6. Okay? So negative 6. Then here, we have a negative 2. So our final answer will be 6 minus 1. We have a 5, negative 6, and a negative 2. This is the single matrix of Mn. Okay, so if you look at the order of this matrix, it's a 3 by 1, just like what we have. So this is some of the tricks that you can use as you are handling your mathematics paper 1. Very important. Okay, if you still have questions there, if you are lost somewhere, please you can ask. I can still go back and explain. Okay, so if there are no questions, then we can proceed to the next question, which is question 8. All right. So question 8 is saying, for the sequence 7, 11, 15, 19, find the ninth term. Okay. So this is AP, arithmetic progression. All right. So the way we handle arithmetic progression, you need to remember now the formulas first of all. So nth term of an AP is what? A plus, open bracket, n minus 1 times D. A represents the first term. So what is the first term here? It's a 7. N represents the position number. So in this case, they are asking us to find the number which is on position 9. So n is a 9. Then D represents the common difference. So we are supposed to find the common difference in this case. How do we find? We say T2 minus T1, all right? So T2 means the term or the number which is on position 2 minus the number which is on position 1. So the number on position 2 is 11, all right? So we'll say 11 minus 7, okay? So here when we subtract, it means we would have found our common difference. So 11 minus 7 is a 4. So our common difference here is a 4. Then let us substitute. So we are finding T9 equals to A is a 7. Okay, then plus, that is N is a 9 minus 1 times 4. Okay, so 7 plus, what is 9 minus 1? 8, then times 4. Okay, I hope we are following there. Then we follow BODMAS. We begin first of all by multiplying 8 and the 4. Okay, so 8 times 4, okay, 16, that is a 32. So 7 plus 32, okay, what is 32 plus 7? Okay, which is giving us 39. So the T9 in this case is a 32. Okay. Any questions so far, guys? If you are enjoying this video, please don't forget to like and share to others so that they can also join. We are still going. Okay, let us go. This was A, and then we are going for B. B is saying sum of the first 16 terms. We want to find sum of the first 16 terms. Okay? So the sum of the first 16 terms, again, we have to know the formula, because if we won't remember the formula, then it ends there. We can't manage. So sum of the nth terms is Sn, then n over 2, okay, square bracket, 2a plus n minus 1, then d, close the square bracket. Okay, so here we're finding sum of the first 16 terms. So meaning n is 16. So 16 equals to 16 over 2, all right? Then 2 times a is representing the first term, which is 7, plus n is 16, minus 1, then times 4. The common difference, the same common difference. Okay, if we divide 16 by 2, we have 8. Okay, then what do we have? 2 times 7 is a 14, plus 16 minus 1 is actually 15 times 4. From here, first of all, we need to multiply. Okay, we follow the BODMAS. Okay, BODMAS is very important in paper 1. You miss it there, then things are sour. Okay, so we have 8, and then 14 plus 60, because 4 times 5 is 20, so 0 carry 2. And then 4 times 1 is a 4, plus 2, which is giving us 6, so 60. Okay, you've seen that I've not multiplied 8 and 14, or maybe multiply. You can't do that until you are done with what is in the brackets, just like what BODMAS wants us to do. Okay, so 60 plus 14, so we have 8 times, this now will give us 74, all right? So now what is 8 times 74? Okay, so we can multiply this one, okay, where we have 74 and then 8. What is 8 times 4? Okay, so 32, that is 2 carry 3. What is 8 times 7? Okay, that is 56 plus 3, 59, okay? So in this case, we have a 592. So 592 is the sum of the 16 terms, 592. That is our answer there. Okay? Any questions before we proceed? Any questions? Any questions, guys? Are you enjoying? Say something in the comments. Say something in the comment. Are you enjoying? Okay, if I'm too fast, please go ahead and comment to say I'm fast so that I reduce my pace. Okay, are we enjoying, guys? Okay. We proceed then to the next question, which is question 9. Okay, question 9 is saying the probability of Masamushi, okay, the probability of Masamushi failing an examination is 3/7. What is the probability that she will pass that particular examination? Okay, pretty simple, right? Okay, so now this is what you do. This is question 9. Okay, so let's say I have an event A. Okay, let me just try to explain this one. Let's say I have an event A. Okay, probability of picking A, and when I add the probability of not picking A, so probability of A and probability of not A, the answer here should give me a 1. When you add these two, the answer will be equal to 1. Okay? This is where we get our concept from. So in this case, this is probability of passing, meaning when I add the probability of failing, the answer should be equal to 1. Okay? So probability of passing, I'll put a P, plus the probability of not passing, okay, which is failing, of course. So let me use the word failing so that we are, then this should be equal to 1. So I've been given the probability of failing. Okay, what is the probability of passing? So probability of passing will be, okay, plus this has been given as 3, then 10, equals to 1. So we are going to make this fraction to cross the equal sign. So probability of passing will just be equal to 1 minus 3/10. Okay, so over 1, and then we find the common denominator, which is a 10. Okay, 1 into 10 is a 10. Okay, what is 10 times 1? It is a 10. Then 10 into 10 is a 1. What is 1 times -3? It is -3. Okay, 10 minus 3, which is a 7/10. So this is the probability of doing what? Passing. That's all. It ends there. Okay. If you have questions, please go ahead and ask. Go ahead and ask. Go ahead and ask. Okay. So that was B. Then we go for B now. Okay. So B, they're saying a plan of a play boat is drawn to scale of 1 to 20. If the actual area of the base of the boat is 0.64 meter squared, calculate its area on the map in square centimeters. Calculate its area on the map in square centimeters. All right, so guys, what you have to know with the scale drawing is that so the way it is given, 1 to 20. The first part here is on the map. Okay, this scale here is on the map, and this other scale is on the ground. Okay, this is the actual on the ground. Both of these, they are in centimeters. Okay, that is one thing you need to know. So the first part here on the left is on the map. This is on the ground. All right. Now, since we now know that this is on the ground and the other one is on the map. Okay. So now, what we are going to do first of all is to convert this, the 0.6. They've given us the 0.64 in square meters, but they want us to calculate its area on the map in square centimeters, meaning this value has to change. It has to go into centimeters. If they wanted me to find the actual area on this, on the square ground, the actual area on the map in meter squared, would have gone direct. But this time around, we need to convert this one. Okay? So how do we convert this one? We know the scale to say 1 meter is equal to 100 centimeters. This we know. Okay? But we are dealing with area. Our values, we need to square these. We need to square the units. Okay? So 1 squared now becomes 1 m squared equals to 100 squared is just 100 times 100, where we'll just add the 4 zeros, so it will be 10,000 in centimeter squared now. So this is now the scale we are going to use to convert this. Okay? So the 1 meter squared is equal to 10,000 centimeter squared. Okay? From here, we get this. So we want to know this value in centimeters, okay, which we don't know. Then we cross multiply from here. So 1 times x is x equals to 0.64 times 10,000. Okay? So here, if you have a number which has got a point and you have zeros, so like in this case you have 1, 2, okay, this point will be pushed to the right 1, 2 times by these 2 zeros, okay, it will become 64. So the 2 zeros will go, then we'll remain with it again other 2 zeros. Then when we multiply, this becomes 6,400. So 6,400 centimeter squared. It's now in centimeters. All right? So after converting now, I can bring this scale which I was given. The 1 centimeter is equal to 20 centimeters. This is the scale. Okay? Now, the unit we are using here is in square. Again, we have to square this. So squaring this, this will be 1 centimeter squared. Then this will be 20 times 20. So 2 zeros, then 2 times 2, 4. So this will be 400 centimeters squared. All right? I hope you are getting it there. Now from here I can convert. Okay? I want to convert the, I want to find now, I know to say on the actual ground, using the scale, this is the scale. So what I know is that this is where, according to this, if the actual area of the base of the boat is this, if the actual area of the, so actual, if you remember what I explained, on the left this is map, on the right that is what? Ground. This is actual. They're saying actual, meaning it is on the ground. So it's supposed to be here. Okay? Centimeter squared. On the map, we do not know. Okay? So we cross multiply from here. All right. So we'll have x times this. So 400x equals to 1 times this to be 6,400. Then over 400 over 400. This will go. Our x becomes, we can cancel the 2 zeros. Okay? 4 into 6, that is 1, remainder, oh no, remainder 2. Then 4 into 24, okay, that's a 6. So we have 16 centimeter squared as your final answer there. Okay. I'm taking in questions. Any questions, guys, so far? Any questions? Any questions, guys? Okay, so no questions. All right, we continue then. With our questions, we continue. Okay. So the question 10 is saying, I hope people are enjoying the lesson. I'm not seeing comments. Let us say something. If you're enjoying the lesson, in case you're not getting me, or the sound is not clear, please say something. Okay. All right, so question 10. We have 10A, which is a set. All right. So the set is saying, given that universal set is equal to 3, 6, 9, 12, 15, and 18, A is equal to these elements and B is equal to that. They're saying list A intersection B complement. So first of all, let me write down the universal, that is 3, 6, 9, 12, 15, and 18. Then our A is 6, 9, and 12. And then our B is 3, 6, and 18. So first of all, before I go with the intersection, I need first of all to find the B complement. Okay? I need first of all to find the B complement. So B complement means we remove these elements that are in B in the universal set. So we remove a 3, 6, and 18. 3, 6, and 18. These are the elements that are not in set B. That is 9, 12, and 15. So this particular set, we're going to say A now, which is this. The elements are 6, 9, and a 12. Intersection with a B complement, which is this set here, 9, 12, and a 15. So what is common in these two sets? Okay, it's just a 9 and a 12. So A intersection B complement, the answer is 9, 12. This is your answer there. Okay. Are you following, guys? Are you following? Okay. We go for B. B is saying solve the equation 3x then plus 3 equals to 27 to the power 5. Okay. So when they say solve the equation, just like we've been saying, okay, when they say solve the equation, they simply mean find the value for that particular variable which is given on that expression. In this case, we have letter x here. So they are asking us to find the actual value for x. That is why they are saying solve the equation. Now, these are indential equations. They are coming from indices. So the way you solve such questions, first you check where is your letter. In this case, our letter is on the exponent. It is on the power. Meaning, you are going to concentrate on making your bases to be equal since your letter is on the power. Okay? So, from here, this cannot be reduced any further. So, this will come as it is. Okay? But the 27 is supposed to be changed into index form with a base of 3. Whether we like it or not, because that's when we can equate these. So now, how many times can I multiply 3 to get 27? Okay, good. 3 times. So I'll put in brackets. Now this power has been raised to another power, right? So this is just the same as 3x plus 3 equals to, 3 to the power x plus 3. Then 3 times 5 will give us a what? A 15. All right? Now the bases are the same, meaning we can equate the powers, okay, by saying x plus 3 equals to 15. Then we solve. This is now an expression. So the 3 crossing the equal sign, we have 15 minus 3 equals to 12. So the value for x is a 12. Okay. Are you following, guys? Tell me if you are enjoying the lesson. Tell me if you are enjoying the lesson. Tell me in the comment sections. I want to read out your comments. Please say something. Say something. Okay. We go for question 11. Okay, question 11 is saying the diagram below, it's coming from 8th geometry actually. So the diagram below shows two towns A and B, okay, on the equator. A is on longitude 35 degrees west and B is on longitude 40 degrees east. Okay, first question is saying find the time at A when it is 18 hours at B. Okay, so the concept you need to know about time is that we calculate time using longitudes because the Earth turns using the y-axis. So it rotates from west to east. No wonder we are using longitudes to calculate time. So after 1 hour, you're supposed to know that the Earth turns 15 degrees. After 1 hour, the Earth makes 15 degrees turn. Okay? Now, for us to be able to calculate time here, it means, first of all, I need to find the difference in longitude of A and what? B. What is their difference in their longitudes? So looking at the longitude for B and the longitude for A, they are on different sides. This is on the east, this is on the west, meaning we add. Okay, so long as the poles are different, we add. So 40 plus 35, okay, we are going to have what? 75 degrees. This is the difference in their longitudes. Now check what we're going to do with them. So here we'll say, since 1 hour, after 1 hour, the Earth makes 15 degrees. Why am I having these degrees? So we are trying to find the time difference. Okay? So now from here, we'll use the degrees. We need to convert these degrees into time now. So 1 hour equals to 15 degrees. What about 75 degrees equals to how many hours? We cross multiply. X times 15, 15x equals to 75. So over 15 over 15. This goes, our x becomes, how many times does 15 go into 75? Okay, so let us try a 5. 5 times 5, that's 25, so 5 carry 2, 5 times this, 5. Okay, so it goes there 5 times, so 5 hours. This is the difference in their time. But now, they have said at B, the time is what? 18 hours. Okay, look at where B is. So B is ahead of time. In terms of time, B is ahead compared to A. Okay, B is ahead compared to A. So when you are going back to the west, when you are going to the east, to the west, you are going to be losing time. When you are going to the east, you are going to be gaining time. So in this case, we are trying to find time for A, which is behind B, meaning it is less in terms of time. So we have to subtract these 5 hours we have gotten from the 18 hours. If this 18 hours was at A and we are trying to find at B, we are going to add the 5 hours, because as you go to your east, you are gaining time. So since we are going to the west, we are losing time. So 18 hours, we'll subtract 0.5 hours from it. So 0, 0, okay. What is 5, what is 8 minus 5? That is a 3, 1 minus 0, 3. So the time in this case at A will be 13 hours. Have you seen the time difference? So at A, it is behind in terms of time. B is ahead of time. All right. Any questions there, guys, before we go to question B? Any questions? Okay, any comments? If you're enjoying, comment, guys. Okay. All right, we proceed then. There are no comments. Okay. They're saying an aeroplane, a plane flying from A to B takes 5 hours. Find its speed. Okay. The formula for speed is equal to distance over time. In this case here, time should be in hours, which is already given. Distance is supposed to be in nautical miles. Okay? When you're calculating speed, because speed we need it in knots. So our distance is supposed to be in nautical miles, time in hours. So we already have time, which is 5 hours, but we do not have distance. So we can calculate the distance here. Okay? Now the distance of AB. AB is seated on, A and B, they are seated on latitude 0 degrees, which is the equator. And the equator, we say, it is just the same as the great circles. Meaning its radius, you can see, they are even indicating here, its radius is the same as that of the Earth. So for us to find distance in nautical miles, we'll just say 60 times the difference in longitudes. So difference in longitudes we found as what? 75. So 60 times 75. I hope you're getting it there. Okay? So from here, we can maintain the 0 and then multiply 6 times 5 is a 30. So 0 carry 3. 6 times 7. What's the answer there? 6 times 7. Okay? So you need to know how to calculate such. Okay? So 6 times 7 will just give us a 42 plus 3, 45. Okay? So the distance now in knots, in nautical miles, is 4,500. Now we can calculate the speed. So speed is equal to distance over time. The distance is 4,500 over, the time is what? 5 hours. Okay? Let us reduce. So 5 into 45. How many times? Okay, so 5 into 45 into 30, that's a 6. Okay, so that's a 9. So here we have 900 knots. So this is your answer here. All right. Any questions there, guys, before we continue? Any questions? Okay. So meaning we are okay there. All right. We go for question 12, which is coming under function, saying the function f and g are defined by f of x is equal to 3 3x, okay, 3x, all right, so defined by f of x is equal to 3x minus 2, g of x is 4x plus 1. Find the f inverse. So f inverse simply means we make x the subject of a formula. So first of all, I'll bring down the f function, which is 3x minus 2. Okay, so we'll say f of x, let f of x be y. Okay, where there is f of x, put y. So here at the beginning, I'm going to say y equals to 3x minus 2. Okay, so from here now, we're going to make x a subject of a formula. So the 2 has to cross. So we'll have y plus 2 equals to 3x, okay, over 3 over 3. This goes, our x becomes y plus 2 over 3. From here now, I'll substitute the f inverse with the, so where there is x, I'm going to put the f inverse here. So f inverse of x, then where there is y, we put what is in the bracket, so x plus 2 over 3. This is the f inverse. Okay. We go to B. B is saying find g f of x, the composite, g f of x. This is a combination of two functions. Now, you have to remember that this function which is coming second, it is the input for g, meaning it has to be put on a function of g. Okay? This is the main function, g. F is the input. Okay? So the g function is what? G function is given as 4x plus 1. So 4x plus 1. F function is given as 3x minus 2. So this function here has to be inserted into g, where there is x. Okay? So g f of x equals to 4 open bracket, put this, okay, 3x minus 2 close bracket plus 1. Okay, we multiply the 4, distributing it inside the brackets. So 4 times 3x will give us 12x. 4 times negative 2, that is negative 8, then plus 1. So from here, negative 8 plus 1, we'll have 12x minus 7. This is the g f of x. It's a combination of two functions. Just remember that when you are finding a combination of two functions, one will be the input, especially the one that comes second. It's the one that becomes the input. Okay. Then they're saying C, find g f of negative 2. So here they're asking us to use the composite of the function. We are not using any of these functions. We're using the combination. So the combination we found as what? 12x minus 7. So 12x minus 7, okay? So that's the function we're going to use. So g f of x, f of negative 2, equals to 12x minus 7. So this number which is inside the brackets has to be substituted where there is the x. So say 12 times negative 2 minus 7, okay? So 2 times 2, it's a 4. 2 times 1, it's a 2. Now, since it's a negative, we are multiplying different signs, so it will be negative 24 minus 7. Okay, then negative 24 minus 7, same signs, we maintain the sign and add. So this will be negative 31 as your g f of negative 2. Okay. Are you following, guys? Are you following, guys? Okay, say something. If you are following, say something. Okay. Let us go for question 13, which says, Chialwa estimated the length of a string as 15 centimeters. If the true length of the string was 14.6 centimeters, find the absolute error. So absolute error in this case, okay, since we have the actual value and the measured value, we are going to say absolute error will be equal to measured length. Okay, so we say recorded value minus true value, okay, with the modulus. Okay, so recorded is 15. So 15 minus actual, the true value is 14.6. Okay, so when we subtract there, 15 minus 14.6, that is 15, then 0.0, then we have 6 point. Okay, so if we say subtract here, we get a 1, this is 10, so 10 6, that's a 4 point, this is a 0, this is a 0. So the absolute error will just be 0.4. Okay, this is question A. Question B is saying find the relative error. Okay, find the relative error. Relative error. Okay, this is B. So relative error is equal to absolute error, okay, over true value. Okay, so the absolute error is 0.4. The true value is what? The true value is 14.6. From here, we don't leave it like this. Okay, we can still simplify it further. So we need to remove the point, and the highest decimal place is just 1. So times 10 times 10 on both sides. So this 4 times 10 will just be a 4. Over this, the point will just be pushed there to be 146. Okay, then we can use a 2. Okay, I think we can use a 2 to simplify this. Okay, where we have 2 into 4, that's a 2. 2 into 14, that's a 7. 2 into 3, that's into 6, that's a 3. So the final answer will be 2 over 73. This will be the relative error. Okay, so I hope, guys, you enjoyed. Join us again as we continue solving these questions. So next time we're going to start from question 14 going forward. Okay, so join us next time as we go live again to complete this paper for 2020. So just a simple tip that I'm going to give you when you're handling paper 1. Please be confident as you are going to solve paper 1. At the same time, there are questions that can give you a lot of marks. Okay, so let me just disclose this one. I bet you've never been taught in school. So let me just show you the questions that you can pick. Okay, actually you only need 45 marks in paper 1. Even 40 is enough. Even 36 is enough for you to get a good mark in mathematics, both papers. Okay, so you have to know this question here. You have to know the question for functions. Okay, you have to know the question for linear programming. Okay, you have to know that is variation. Okay, we'll give it a benefit of doubt. Let us, but these are just direct. I'm just giving topics that, in case this topic is still a challenge to you, you can still get to us. But you have to get this one correct as well. Okay, you have to get bearing correct. All right, you have to get functions correct. You have to get the errors correct. Okay, you have to get the sequences correct, the set and the matrices correct. Then all these here, you have to get them correct. Okay, so it's not all the questions that you can solve in paper 1. Okay, so there's a tactic that you can use. You can just go for questions that can give you marks. Okay, that is how we handle paper 1. So join us next time as we talk about the topics and the questions that you can concentrate on as you go in studying for your exam. So thank you very much, guys.